Welcome back, student, to section 11.4. It's the comparison test. In this example, I will use the limit comparison test. So I need to compare my sequence here, which is 9 over 3 plus n. I need to compare it with something simpler and something that we know the answer for. Let's use the same idea we did for the other functions. So let's choose Pn, and we will take the dominant term in the numerator and the dominant term in the denominator, which is kind of at the highest power or something similar. In the numerator, we just have 9 to the n, so here I will write 9 to the n. Now, if you compare 10 to the n with 3, which one is the dominant? Which one is the give you the largest values with the time with n goes bigger and bigger? It will be 10 to the n, because the 3 will still 3 all the way. So this is 10 to the n, 10 to the n, which is 9 over 10 to the n. Now this seems to be simpler, okay? But the question is whether this is converges or diverges. We need to check that up here. So I have this sequence, 9 over 10 to the n. I want to check if this is converges or diverges, so just let me write the first few terms. Supposingly we start from 0, 1 doesn't matter. It will be 1 plus 9 over 10 plus 9 over 10 square plus 9 over 10 cube, and so on. Do you remember something like this? If we divide the next term by the previous one, we get always the same answer, so that we call it R, and that is the ratio, the common ratio. Since R is less than 1, okay, the series converges. Why it converges? Because this is a geometric series. Go back to section 11.2 and you will see all the information. So if R is less than 1, the series converges, and the exact value we already know it. We don't need to write it down, but we know it. The exact sum is 1 over 1 minus R. Okay. And the most important for us is that it is converges. That's the most important piece of information. So I will compare my series in the question with a convergent series. The best way is we use the limit comparison test. So we need to find L, and L is equal the limit as n goes to infinity. You write an, the one in the question, over bn, which is the one that you have thought of. The one in the question is 9n over 3 plus 10n. bn is 9n over 10n. You have a stack of 4. So you take the first with the last. Okay. So 10n would come here, and 9n will stay here. First with last, second with third. I think I can see cancellation. 9n with 9n. So finally I will get this, which is 10n over 3 plus 10n. I will use L'Hopital if you want. You can use anything you would like, actually, it doesn't matter. So I will get 10n ln 10 over 10n ln 10, and the answer would be 1. And since the answer is 1, which is between 0 and infinity, we conclude using the limit comparison test that this series and this series, they have the same behavior. And that's the important piece. Both of them, they have the same behavior. Okay. And if they have the same behavior, since Pn is converges, this one converges. Okay. Other questions, please let us know. I will move now to the next one in the same video, example 6, which is this one. As we did before, we need to compare it with something simpler and well known. We know if it's converges or diverges. N is n, so let me just try to guess. Let me do n here, and let me compare len n. I will just compare it with 1. I'm not sure if this will work, but this is simpler. This is, I know if it's converges or diverges. Can you tell me why this is converges or diverges? This series diverges. By which test? The p-test with b equal to 1, which is this then equal to 1. Okay, because the power of p here is 1. Now we need to find the limit, which is L equal limit as n goes to infinity. Here we have an over Pn equal to limit n goes to infinity. An is ln n over n. Bn is 1 over n. I think we need to do the cancellation. It's a stack of 4, so let's put them together. There will be cancellation, n with n, and the final answer will be limit n goes to infinity ln n, and the final answer is infinity. Now let's check if we get the number infinity, what can we say? I will go back to the limit comparison test and we'll check. Look at number 3. The limit is infinity. The series Bn diverges. So what can we say about An? Diverges. Let's go back to our question and let's check, do we have the same scenario or not? First of all, the limit is infinity. The Bn diverges. So An will be diverges. So by the limit comparison test, this series, which is ln n over n, diverges. Okay, so we conclude that this is diverges. Thank you. Next would be example 7.